Now, important thing, what is the expression for cross product when the two vectors are given in terms of I, j, k in the component form? Okay, so see here, this is called component form, means when vectors are represented in the form of I, j, k, that is called component form of a vector. As we all studied, the dot product of, in such case, vector a dot b is how much? A1 a2 plus b1 b2 plus c1 c2, means sum of the product of the coefficients of I, j, k. Similarly, there will be an expression for cross product when two vectors are given in terms of their components. Let's straightforward understand this, and there is a proof for this also. Okay, so the cross product of such two vectors is given by determinant I cap, j cap, k cap, and the second row is coefficients a1, b1, c1, and third row is a2, b2, c2. How it has come, from where you have derived, means there is a proof for this. In the textbook also it is there, so you can go through the textbook, or I will be giving one detail, so you can take screenshot of this. I will not be proving this, proof is not so important. Okay, so just you can find the cross of these two term by term, you apply cross product, and whenever I cross I comes, you write j 0, whenever I cross j comes, you write k. So likewise you will get one expression finally in this form, so which is nothing but your expansion of the determinant this. So better go through the textbook and find the proof. Otherwise, if screen is clearly visible, then you can take the screenshot of this and work out. We will move on to the problems. Okay, problems are going to be standing one, easy one. So here vector A is given as this and vector B is given as this, and you are asked to find what is A cross B and its magnitude. Very easy. Write the formula for A cross B in the component form, in the form of Ij A. So here is the formula. Substitute, expand the determinant that you studied in determinant chapter, that is I cross into 1 into minus 2 minus 2, 3 into 5 minus 15, minus j cap into 2 into minus 2 minus 4, 3 into 3 9, next plus k cap into 2 into 5 10, minus 3 into 1 3. Simplify this, you will come up with this. Then we want its magnitude. Okay, magnitude means under the square root sum of the squares. So 17 square, 13 square, 7 square. So square them and add, you will get square root of 507. We'll move on to next problem of same kind. You have to work. So A is given, B is given. You are asked to find A cross B and magnitude of A cross B. As earlier, say that. I hope you will do it. Okay. So determinant expansion has to be made perfect. Okay. So here is one more example for your understanding. Please take screenshot of this and work. Answer is square root of 722. So here you will come to know that how the cross product of two vectors can be found and how the magnitude can be found, because the same thing we use in finding the area and area of triangle, area of parallelogram. Okay, so we'll studying the next part. Okay. Now here, find the unit vector perpendicular to each of the vectors A and B. So now you have to find unit vector which is perpendicular to both A and B. Okay. So as I mentioned earlier, if there are two vectors making an angle theta, then the vector which is perpendicular to both the vectors is A cross B, and you have to find what is the unit vector along A cross B, that you have to find. Okay, so that is n cap you have to find. So we know that A cross B is vector which is perpendicular to both vector A and B, as I mentioned earlier. Okay, so first you have to find what is A cross B. So as earlier, A cross B is this much. Okay, so by determinant expansion, expand it, you will get this. This is your A cross B. Now you have to find what is unit vector along this direction. Okay, now this is your A cross B. Okay, now we want unit vector along this direction, means n cap you want. So how will you find any unit vector in the direction of any given vector is? You have to divide that vector by its magnitude. So we will divide this vector by its magnitude. Okay, and remember that there is one more vector which is perpendicular to both the vectors but in the opposite direction. This is minus n cap. So unit vector which is perpendicular to both A and B can be written as either plus this or minus this. Okay, so I can write plus or minus this. Now this is already found, this, and its magnitude is 6 square plus 8 square plus 5 square. Simplify, you will get square root of 125. Okay, so this is the unit vector which is perpendicular to both vector A and B. Okay, if you take plus sign, this is the vector, and if you take minus sign, this is downward vector. Okay, now we'll move to next problem. Same concept, but little difference is there. Find the unit vector perpendicular to each of the vectors A plus B and vector A minus vector B. Okay, think that you have to find unit vector which is perpendicular to this and this. Now you are given A and B. So first you have to find what is vector A plus vector B and vector A minus B. So we call this vector A plus B as vector P. Okay, we take this as vector P and add them, you will get this. Okay, 3i plus I is 4i, 2i plus 2i 2j plus 2j 4j, and likewise 2k minus 2k cancels, you will get 0k. Similarly, write q as A minus B and subtract them, you will come up with this. Okay, now we got A plus B and A minus B, that is P and Q. Our intention is to find unit vector which is perpendicular to these two, means which is perpendicular to P and Q. Okay, so as we discussed earlier, you have to find unit vector in the direction of P cross Q. That is the required result. So first find P cross Q. So P cross Q is, as earlier, by the determinant you found what is P and what is Q. Okay, so write their coefficients, expand it, you will get this. Take screenshot. Let's move on to finding n cap. Okay, so now to find the unit vector which is perpendicular to P and Q, so let's see, n cap is plus or minus this, as earlier. Simplify. Okay, this is the required. There's nothing to explain here. Everything is straightforward. Only thing is that determinant expansion must be correct. Otherwise, you will lose your marks. So I will be giving one example as a homework. Please try this. Take a screenshot. Okay. Answer is given here. Pause the video and note down if you wish. Otherwise, you can forward the video. Okay, final answer will be this. Better you take screenshot. So vector, it's a simple one, but the thing is that basic concepts must be clear. Otherwise, you will lose unnecessarily good number of marks. Okay. Now we have to show that what is the cross product of this. Okay, means you have to show that vector A minus B in cross vector A plus B is 2 into A cross B. So let us start with LHS. Take LHS as this and simply apply the distributive property. You can write A cross of A plus B minus B cross of A plus B. Just multiply term by term. That is apply distributive property. A cross A cross B minus B cross A minus B cross B. As I said earlier, A cross A, B cross B, 0 because the cross product of two similar vectors is 0. So you can write this as a 0 vector and this as it is, and we know that A cross B is equal to minus of B cross A. So you can write minus B cross A can be written as A cross of B. Okay, so addition of these two gives you 2 times A cross B. So remember that minus B cross A can be written as A cross B. Now here is one example. Find the value of lambda and mu if the cross product of these two vectors is 0 vector. So write the given, very simple. Write the given as this, and the cross product of two vectors can be represented in the form of determinant. So here coefficients of ijk are 2, 6, 27, that is the first row, and 1 lambda mu is the third row. Second row, this is second row, and this is third row. Now expand this. I have expanded here I into 6 mu minus 27 lambda minus j cap into 2 mu minus 27 plus k cap into 2 lambda minus 6 equal to 0 vector. Okay, so 0 vector can be written as 0i plus 0j plus 0k. Okay, let's see here. So this is equal to this. Now you have to equate the corresponding coefficient because this is stated as this is a 0 vector, means coefficients of I, j, k must be 0. So equate the coefficients of I, j, k to 0, you will get the value of lambda and mu. So equating this coefficient with the coefficient of 0. So it is 0. Coefficient of, so what you will get? 2 lambda minus 6 equal to 0. So solve this for lambda. 2 lambda is equal to 6, that is 6 by 2, and that gives you 3. Similarly, equate this with 0, that is minus 2 mu minus 27 equal to 0. So on solving this, transferring minus this side means you will get 0. So solve this, you will get 27 by 2. So substitute these two values in this, so you should get 0. Then only your results are correct. So just verify. So if you substitute mu and lambda here, okay, I have substituted here. This 2 ones are 2, 3s are, you left with 3 into 27, 3 into 27, they get cancelled, which is 0. So these are the correct values of lambda and mu. Now there is one more example here. If A dot B is equal to 0 and vector A cross B is equal to 0, what you conclude about the vectors A and vector B? So as we know that how the dot product is defined, A dot B is defined as this. A dot B is defined in this fashion. The cross product is defined by this formula. Now we know that if the dot product is 0, then what will happen, and if the cross product is 0, what will happen to vector A and B? Whenever the dot product and cross product are zeros, definitely one of the magnitude of A and B must be 0, because these depends on the magnitudes of A and B. Okay, so if one of the magnitude is 0, then definitely this will happen, because theta vary here. If theta is suppose pi by 2, so this is going to be 0, but this is not going to be 0. Okay, so we are asked what we will conclude about the vectors A and vector B. So vectors A and vectors must be such that one of the magnitude must be 0 in order to both the products becomes 0. So this is the implication.